We're going to practice finding the inverses of some exponential equations. So remember, each of x just means y. So we're going to switch these and say x equals 4 to the power of y plus 3 minus 7. So if this currently is an exponential equation with a base of 4, our inverse should be a log base 4. So just keep that in mind as we're working through this. But you're just going to undo our steps here. So we're going to add the 7. X plus 7 equals 4 to the power of y plus 3. So to undo an exponential base, we take that base over to the left-hand side, and it now becomes a log base 4 of whatever was over there. That undoes that base 4, and what comes down is just the y plus 3. The more you do these, the more you will get a hang of them. So log base 4 now of x plus 7 equals y plus 3. If we're trying to solve for y, we need to subtract that x over. So log base 4 of x plus 7 minus 3 equals y. Again, you can leave it as this, but I would really write it as inverse notation. So h to the negative first of x. So as you're doing these, if you start with an exponential equation with base 4 and you end with an exponential equation base 4, if you're finding the inverse, we did something wrong. If it starts as an exponential, it needs to end as a log. So let's go over here to number 4. Switch your x and y. X equals 1/4 to the power of y plus 1. So if there was something being multiplied or being subtracted, we would take care of those things first. But because there's not, the very first step actually is just undoing the exponential piece and bringing this over and making it or turning it into a log. So this will just be a log with a fraction as the base. So log base 1/4 of what's on that left-hand side, x equals y plus 1. We don't have y by itself quite yet. All we have to do is subtract the 1 over. So log base 1/4 of x minus 1 equals y. I'm going to write it in inverse notation. So that was it. 3 steps. Switch your x and y. Bring the base over. Subtract 1. So number 5, we're going to make this x equals 5y, or 5 to the power of y, plus 1. So first step's going to be to subtract that 1 over, equals 5 to the power of y. So now all we have is that exponential piece. So we need to undo it by making the left-hand side into a log with that same base. So log base 5 of what was over there, x minus 1, equals y. So in this case, we're actually done. Again, just inverse notation. This here would technically be fine, but log base 5 of x minus 1 equals f to the negative first of x. Okay, let's do one more. Number 8 with our fraction here. Same thing, first step. Switch x and y. X will equal 2 to the power of y plus 8 over 4. So the first thing I would do is multiply both sides. Multiply by whatever your denominator is. If you want, you can put it over 1. But what happens is that will cancel that out, and you'll be left with just that numerator on the right-hand side. So 2 to the power of y plus 8 now equals 4 times x, so 4x on the left. Okay, we're going to subtract that 8 over. So 4x minus 8 equals 2 to the power of y. So the last step here is going to be to undo the exponential piece with base 2, and the left side will become a log base 2 of what? Of what you had over there, 4x minus 8 equals y. So you would be good here, but again, for inverse notation, I'm just going to rewrite this as log base 2 of 4x minus 8 equal to f to the negative first power of x. This would be fine for me for just writing it mathematically correct. I always write it with that negative 1 power. But just getting to the y equals is fine. They mean the exact same thing if you were to type them into the equation. So just remember, if you start with an exponential equation and you're finding the inverse, you should not end with an exponential. Exponentials turn into logs, so you should end up with a log in your end result there.